Okay, let's talk about Lab 5, specifically the third sequence in Lab 5 where your cylinder is going back and forth and back and forth and back and forth, and when you hit stop, it continues to go out and then stop. So whenever you hit stop, it continues the current stroke and then stops. So if it's going out, I hope you're listening to this. If it's on its way out and you hit stop, it keeps going and then stops. Now, that's a little difficult because you know that if I terminate the solenoid, then the cylinder will retract. So you've got to keep the solenoid energized, and when it goes out, you still have to keep it energized. So when you hit stop, it's not turning the solenoid off, it's doing something else. It's just not allowing it to retract. Okay, so what we're going to do is we're going to study that concept of not allowing it to retract or not allowing it to extend, not by actually turning on and off the thing that makes it extend and retract. We're going to turn off the signal that tells it to extend or retract. Okay, let's take a look at this. Now, I want to give you the answer, okay? So what I'm doing is I'm unpacking that with a totally different cell, different concept entirely, but it's something you're not unfamiliar with. So over here, we've got this tank that's being filled and emptied and filled back and forth and back and forth. So you guys already know about the tank filling up and lowering and going up. Now we had a heater in there last time. This was from 110, okay, last semester. So what's going on here is I've designed the same kind of thing, except when you press start, it goes up and down and up and down and up and down and up and down continuously. We're going to add in the concept of if I hit stop, what it's going to do is it's going to continue going up and then it's going to stop. Or if I stop it on its way down, it will continue to go down and then go here. It's not going to just turn the pump off and turn the drain off and the water's just going to sit there. It's going to continue its cycle and then it's going to stop. So let's take a look at that. What I've done is I've kind of just built the circuit to make it go back and forth and back and forth, up and down and up and down. I want to point out a couple things here. Before we move forward, I want to state that the event that makes it start to go up is not the start button. The event that makes it go up is the fact that it went down. The event that makes it go down is the fact that it went up. But you have to get out of, and by the way, this is important for the second part of Lab 5, you have to get out of the concept where the reason the cylinder starts to extend, now Lab 5 is back and forth, back and forth. No, I think, yeah, Lab 5, actually, this is the same one. In Lab 5, Section 3, it goes back and forth, back and forth, back and forth continuously. And you've got to get out of thinking the event that makes it go out is that you hit the start button. No, it's not that anymore. The start button event starts the whole sequence. It doesn't start it going out specifically. What actually makes it start to go out is that it went in. What makes it go out, what makes it go in is the fact that it went out. Let's continue. With that same concept here, what I've got is, I've got my start-stop rung here, and I've put the contact from here, there, and there. So these are my two main rungs. This rung actually fills it, this rung empties it, back and forth and back and forth. So sometimes that's active, sometimes that's active, depending on what's going on. But the reason I'm starting them, the reason I make these guys do their thing is because I've hit start. The reason that this pump comes on is because the lower float switch activated it. And I've got my float switches separated. We'll talk about that in a second. The reason the drain comes on, that's when it's full, is because the upper float switch indicated that it was full. So the action that makes the drain come on is the upper float switch. The action that makes the pump come on is the lower float switch. I think that makes sense. Or the fact that it emptied or it filled. Okay, so what I want to do here is I want to say, the reason I'm doing this, there are a couple things here. One, that is normally open and that's normally closed. We'll see why that's true in a second. But what I want to do is I want to say, well, why didn't I just put this right here? And why didn't I put this, why didn't I put this right here? And why didn't I put this right there? Why don't I just put them in there? Why do I have to put them on relays? Well, the reason is because, one, I have to reverse the logic of these. And the other is that I have to multiply their signals. And that's what we do with relays. We use a relay to reverse logic or to multiply a signal. We can also use a relay for a latch. And we know about that. That's latching and that's latching. Or we can also refer to that as a holding circuit. So what's going on here is that my upper float switch is actually used here. Now, I've written from upper float switch. You don't have to do that. I've just written that there, and you'll see that. You might have remembered that from the labs in 110. I wrote that there. But just to indicate that that's what's going on. This is what this contact is for. It helps me with my programming. It helps me with kind of running through the circuit and kind of watching it work. Okay, so that's for my upper float switch. Now that's my R4-1. Oh, I've got one over here as well. Not only do I have one here, but it's a reversed contact. That's a normally closed, that's a normally open. Dude, this is so cool that I can use a relay to not only multiply a signal, but also invert one of them, or find the reverse of the other. Okay, so now the other thing is that this guy is a normally closed. The reason I made that normally closed is because I've got to put that up here. But what's happening is that if I made it a normally open, I'd have to actually put a normally closed contact in there, and I don't feel right about that. I don't like to put normally closed contacts and hold them, although it happens sometimes. But I just kind of wanted to avoid that. So I made this normally closed so that I can make that normally open, and over here we can see that this guy is a normally closed, and I like that because that is a termination contact, and I like my termination contacts to be normally closed. Now, if I were to make that a normally open, that would have to be a normally open, and that would have to be normally closed. Okay, let's continue on and look at the logic of how I make this thing stop if it's going, when I hit the stop, it continues and it goes all the way to the stop, all the way to the top, and then stops. So it doesn't turn the pump off right away. It leaves that pump on until it gets to the top, just like you're leaving the solenoid on until it gets all the way to the out. Okay, also what we're going to do is we're going to leave that drain on until it gets all the way down to the bottom. Let's check it out. Okay, so what happens now when I press play here, this becomes closed, that becomes closed. This guy is closed because the water is down here. So because that's closed, and then the pump will start to come on. Now the reason I need the holding circuit there is because as soon as the liquid, when the event is, when the liquid goes above the lower float switch, this is actually going to become open. No, yes, it will become open because this will become open and then that will become open, and I'll lose the signal to my pump. So I'm latching onto that. Same thing's going on here when it's emptying. That's my drain cycle. So the drain cycle starts when it gets up here, but I can't just use my upper float switch without latching onto it, because as soon as the liquid goes below the lower float switch, the event of the liquid going below the lower float switch, it will disappear, or that event will make this contact become open. So I need to latch onto that. Okay, good. So you can just kind of think about this circuit, why it's going up and down, but it will. Now, what do I do to make it stop? Right now, if I hit stop, wherever it is in the cycle, it will just stop. If it's on its way down, it will stop in the middle. If it's on its way up, it'll stop in the middle. If it's at the top, it will stop. If it's at the bottom, it will stop. But however it looks, what we're doing is we're essentially turning the pump and the drain off. We don't want to do that. So what do I do? Well, I can't do it like this, because what I'm doing is I'm just shutting everything down. I need it to stay on. So again, going back to what I said at the beginning of this video, I'm not focusing on turning off the solenoid. I'm not focusing on turning off the drain and turning off the pump. What I'm doing is I'm focusing on shutting down the signal that tells the drain to start and tells the drain to go. I'm just turning that off. How do I do that? Well, going back to one of the other videos that I did in a lecture video where we actually had a holding circuit that had two things in it, what I'm going to do is I'm going to do that. I'm going to kind of expand that concept over here. I'm going to take this guy and I'm going to put him over here. I'm going to take this guy and I'm going to put him over there. I'm going to remove this from here. And I'm going to remove this from here. I'm going to put that in here. R1-2, R1-3. What I'm doing now is I'm letting these guys still do their work, because I need this signal to terminate that. I need this signal to terminate that. So I can't actually just do this. R1-2, R1-3. 3. Whoa. I can't do that because I need these things to terminate the pump, terminate the drain when it's empty and terminate the pump when it's full. So I'm going to actually put the termination, or I'm going to put the stop contact in here and in here, because I want to target where my signal from whatever action is actually doing what it is that I want to shut off. Wait a second, let me go over here again. What I want to do is, I don't want to turn off the signal itself, just shut the sensor down. Nope, turn that sensor off. No, I want to find out where that sensor is doing work for me that I want to manipulate. In this case, this sensor down here, or this switch in this case, the lower float switch here, I want to turn it off where it's going to do this. I want to turn it off where it's going to do this. So I want this holding circuit to stay active until that's done. And then if I hit stop, when it actually gets full again, let's say it's going up. Okay, it's going all the way up. This is staying active. The pump's on until it gets full. This becomes open, and then it's just going to stay there because that's also open as well. So this drain is not going to come on. Do you see that? That is how you deal with Lab 5 Sequence 3. Don't focus on shutting the solenoid down. Focus on turning the signal off from the event, but not directly from the sensor itself. In this case, our sensor is a switch, the outside limit switch. Focus on trying to find out where that limit switch is doing its work and shut that down. Good luck with Lab 5 Section 3. I think you guys are good.